Hi, everyone. It is really great to be here. As Damien said, my name is Hal Triedman, and I'm a privacy engineer at the Wikimedia Foundation. Today, I will be delivering a talk about publishing Wikipedia project usage data with strong privacy protections and without tracking. So just a quick overview of what I'm going to be talking about today. First, I'm going to be giving some introduction and context. Then we'll be getting into the meat of the talk, which is about our pilot project, problem description, some discussion of tensions between data minimization and differential privacy, and then a proposed solution that we have, which is anonymous client-side filtering. Finally, we'll be discussing some open questions. I really want this to be a discussion, and I appreciate the questions that were asked last session. I'm hoping to get some myself. So let's start out here. So the Wikimedia Foundation, many of you probably have heard of us. We are a nonprofit. And our most famous project that we host is Wikipedia. However, we also host a whole bunch of other projects like the Wikimedia Commons, MediaWiki, Wikidata, and we're a relatively large website, the 7th most visited site in the world with around 22 billion page views per month. Now, most people here will be familiar with English Wikipedia, but we actually have 803 active projects spanning 316 languages with visitors from every single country in the entire world. So that's a lot of data that we collect, a lot of page view data, a lot of editor data, and that data is largely governed by a couple of different policies. The first one I'm going to be talking about here is the open access policy. And the open access policy basically states that our intention as an organization is to make as much data about what we're doing, what users on our platforms are doing, as publicly available as possible to researchers, to editors, to other users. And that takes a couple of different forms. The first one you may be familiar with. This is a public edit history for the page on English Wikipedia about differential privacy. Every single page on Wikipedia has one of these revision histories. You can see all of the changes that have been made publicly. There's discussions oftentimes that are also happening about these changes as well. We also publish other types of statistics though. This is from a project that we have called Wikistats. So we publish page views by country and by project, which is roughly corresponding to language usually, edits, registered users, and some stuff about content as well. We also have a lot of this data accessible programmatically through a REST API. You can see here, there's page view data, unique device data, editor data, edits data, a whole bunch of other things. And broadly speaking, in the past, we've been using what Jerome called, I think, some informal privacy methods. So we use filtering, i.e., not releasing page view data for countries where they have a history of restricting press freedoms, for example, thresholding, so saying, arbitrarily, maybe a page with less than 1,000 viewers should not be released, and bucketing, which is just, our informal term for k-anonymity. Now, on the other side of the coin, contrary to the open data values that we have something called a lean data diet, which I believe was presented about a couple of years ago at PEPR. And this is defined largely by our privacy policy and data retention guidelines. Broadly speaking, what it says is that you don't need an account to read or edit Wikipedia. You can do anonymous IP editing, is what we call it. There's no tracking cookies, and we'll get a lot more into this later, but what we do is we get something called an actor signature by hashing the device IP address and the user agent, which is an imperfect metric, but we'll be talking a lot about that further on in this presentation. And finally, we don't save data forever. Almost all of the data that we have is aggregated and anonymized and deleted within 90 days of its collection. So between the lean data diet and the open access guidelines that we have, there's a tension between privacy and transparency. And into this tension, our thesis as an organization is that differential privacy could be a useful tool. So broadly speaking, we are using DP to try and ease this tension and get a more specific privacy guarantee. So let's get into the specific pilot that we've been doing. So a problem statement. As I mentioned briefly before, we release page views by country. And we also release page views by language. The question that we want to ask here is, can we use differential privacy to release page view counts by both project and country? And this is a pretty basic approach, algorithmically speaking. For each user, you define the sensitivity by defining the number of views per page and the number of pages that they can view. You truncate the data set to go to that sensitivity, and you just do a simple group by country, project, and page, and sum all of the counts there. In order to do this project, we've been working with Tumult Labs. They are a great organization. You'll be hearing much more about their platform, I think, later on today. And we've been sort of implementing betas, trying to think about this problem and specifically get into some of the more difficult project-specific issues. So why is this a useful problem to solve? It's useful for editors and for researchers because we can disaggregate trends within languages that are spoken across many countries. Some examples here are Spanish, English, Arabic, Vietnamese, Chinese, and a whole bunch of other languages. And just to sort of give you a sense of what this looks like, right now, we only publish statistics for English Wikipedia as a whole, right? And most English Wikipedia users are based in the United States. Because of that, English Wikipedia browsers in Nigeria, who might have completely different interests and be searching and looking at completely separate things, their page views are getting completely clobbered. So if we can disaggregate these trends, we might be able to give editors and viewers in specific countries a more precise view of what their constituency is looking at. Secondly, from a technical perspective, this is the largest and the most unwieldy data set that we have. It's around 1.5 or 2 terabytes a day. And if we can successfully do it here, we can pretty much do it anywhere within our stack. Now, on the flip side, why is this a difficult problem to solve? There's a pretty high cost of failure. In the past, Wikipedia has been censored. There are a whole bunch of sensitive topics that might be criminalized if people were found to be looking at them. And then also, most importantly, as we've seen during the Russia-Ukraine war, unmasking of editors can have serious legal or sometimes physical consequences. So there's a really high cost of failure here. In addition to that, there are many country project combinations that identify really small user groups. So imagine people browsing Malaysian Wikipedia in Luxembourg, right? There might only be 1 or 2 people. And if we release that data, that cross tab, we might end up just completely releasing the information that those 1 or 2 people are looking at. Now, a third problem that we have is minimizing data collection, which conflicts with differential privacy. So I think about these problems in a couple of different buckets. The first 2 problems are what Jerome was talking about in the previous presentation, and they mean that we need to do differential privacy carefully. The third problem, on the other hand, means that we need to do differentially private aggregations differently. And for that reason, we're going to be focusing the rest of the presentation on this third problem. There's a fundamental tension here between data minimization and differential privacy, because minimizing data collection impedes defining a strong, meaningful, and explainable notion of privacy protection for use in DP. The real heart of this issue is what I was alluding to before when I was talking about the actor signature. What is a user in our system? So just to be sort of pseudocode specific, an actor signature is just the MD5 hash of an IP address and a user agent. And this is a completely imperfect metric. There are a couple of different failure cases here, 2 to be specific. The first failure case is that one user could have many signatures. So let's say someone is browsing on mobile, they switch cell towers, and their IP address could change while they're browsing. That would mean their signature changes as well. In that case, they would be registered in our system as multiple people. On the other hand, failure case 2 is the converse of that. Many users get hashed to one signature. So many users could have the same IP address and user agent, so they would all hash to the same thing. That would mean all of their page views are registered in our system as one person. So just to do a little bit of further analysis on these failure cases, failure case 1 sort of linearly degrades the privacy guarantees of differential privacy. to the extent that someone might be switching IP addresses or switching browsers. This is a really meaningful issue for areas where most browsing happens on mobile, particularly areas in the global south like India, Indonesia, Mexico, and others. In failure case 2, data that could be included in the count is unnecessarily dropped. And this is a meaningful issue for browsing within institutions where people might all have the same devices or potentially the same Wi-Fi networks as well. So a question that you might be asking yourself is, why not just implement first-party tracking cookies, right? We, that would be a simple solution to solving this problem. We actually do not want to know that data from multiple distinct devices, browsers, or networks comes from the same user, because knowing that would be fundamentally in tension with this, the principle of knowing that, of not knowing that rather, is fundamentally in tension with a system that bounds contributions from each user across all devices, browsers, and networks, which, I'm alluding to differential privacy here. Now, cross-device user matching and device fingerprinting are very well-researched areas, and we are deliberately choosing not to implement that research. Data releases, like all code, encode our values, and the stated values of our lean data diet conflict with a system that provides precise privacy guarantees. For the Wikimedia Foundation, unlinkability and minimization of data collection are actually more important than precise privacy guarantees. At the same time, we can just still do better than just the actor signature, though. So I'll be talking a little bit now about anonymous client-side filtering. The goal of this is that we have a cookie attached to each web request that tells us whether or not a certain page should be included in the differentially private aggregations for that day up to some threshold K. Why is this better, and how does this address our 2 failure cases? For failure case 1, one user, many signatures, the stability is better than actor signature because cookies are cleared and the browser changes much less than the IP address changes, especially on mobile. For failure case 2, disaggregation is possible because distinct devices will all say to include their first K pages. So if you have 10 people browsing and K also equals 10, you would have 100 pages that are included rather than just 10. This is a pseudocode implementation sketch that we have here about how this might work. So we have a cookie, which we're representing as an array, a salt, which is a global random string that's stored on the server and regenerated daily. And upon each page view, what we do is we get a hash, the first 3 characters of a URL plus the salt. And then for each existing hash code within the cookie, we rehash that same code. And if code is not in the cookie, then we rehash everything else and append it to the end. It's sort of it's a nuanced thing, but at the same time, we are confident that it will both not provide a unique identifying string for a given user, and also because it changes every page view, provides a certain measure of security. So some strengths, daily rotated global salts mean that server access is not the same as decoding page views. And because the salt expires at midnight UTC, there's no connections across days. As I mentioned before, rehashing cookies upon each page view means that there's no connection across views. And then the reason why we chose a 3-character hexadecimal fingerprint for each page view is that there are 4,096 combinations. We're provisionally going with 10 page views to be included in a single user's contributions. For 10 page views, there's only a 1.1 chance of collisions within a cookie. In reality, this is probably actually even lower because most people, I think 95% of people don't get to 10 page views on Wikipedia within a day. And for English Wikipedia, any hash code could refer to 1,500 separate distinct pages. That means even if an attacker was able to decode or find a specific, they had the global salt and they were able to find a specific URL that hashed to the same thing that they found in a cookie, there are 1,500 separate pages that also hash to the same thing, which is a fair definition of privacy in our question, or in our system here. So some open questions. I'm going to break them up into two broad tranches. The first set are with regard to the anonymous client-side filtering. How do we communicate these concepts with a wide audience that is highly privacy conscious? Does this system of anonymous client-side filtering provide a strong enough privacy guarantee? And then finally, this is just a problem that we've been running into. This is a difficult system to test the efficiency of without actually compromising user privacy more broadly. With regard to differential privacy generally, how do we continuously monitor pipeline output metrics and address data drift that occurs? And finally, how do we educate stakeholders and specifically editors, which are our most outspoken and important community, some of whom could be ostracized, penalized, or prosecuted even because of what they read and write on Wikipedia, on the purpose, scope, and protections of DP. And given this context, how do we configure our algorithms, set epsilon delta sensitivity and release threshold correctly? And how do we configure them appropriately and with informed community input? Thank you so much. I will be going over to the Slack and hopefully taking some questions now.